use trend lines to make predictions. So we're continuing with the scatter plots from yesterday, but now we're going to draw a general trend line through our scatter plot in order to pull data and make estimations, conjectures, predictions about possible outcomes. So for number 1, the table shows the life expectancy in years for people born in certain years. All tables are set up as X, Y. So years since 1900. 0 years, 10, 20, 30, 40, 50. So 0 years from 1900 would be year 1900. 50 years from 1900 would be year 1950. 100 years from 1900 would be year 2000. With the life expectancies listed. So we need to create our scatter plot so that we can build a trend line. So first we need to label our axes. So the x-axis is years since 1900. The y-axis is life expectancy. And we're going to plot these points. So as you see, our data is not a perfectly straight line, but it's a scatter plot that we can work with. So a trend line, also known as a line of best fit, is a line that is very close to most of the points. Essentially, a good trend line would have the same number of points above and below the trend line. So using a ruler, we always use a straight edge. We're going to draw a trend line, a line that is close to most of the points and trying to have approximately the same number of dots above and below. Since I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 points, I'm going to want approximately 5 or 6 above and below. Some of them will land on the line, which is okay. So if I were to lay it here, I see about 6 dots on the bottom, which I would assume would give me approximately 5 on the top as well. And I know my starting point is at 47. So after looking at it, I could have probably scooted it up just a hair higher, but this still has points below, above, and below. So, look at A. Construct a scatter plot of the data. We did so. Then draw and assess a trend line that represents the data. So, based on the line that we just drew, the points are on or very close to the trend line. This is a good representation of the data. So then for B, it asks, write an equation in slope-intercept form for the trend line and interpret the slope and the y-intercept. So we're going to go back to what we know. B is our y-intercept. We can find the y-intercept from either the graph or the table. If it's in the table, use that. If it's not on the table, use what you get from the graph. Find from graph or table. All right. M is our slope. How we find slope is we are going to find 2 points on the line. We're going to be specific here. On the line, not points from the table. We are trying to find the slope of the trend line, so we need to find points on the line, not points from the table. So we're going to start with slope, come back up to our graph. We're going to find 2 points that look to be pretty exact on our trend line. It appears to be an exact point at 20 and 55. It's really close to a point of intersection, an exact crosshairs, and again at 180. From these 2 points, I like to circle the exact intersection points that I used, and then let's count our slopes. So we always do rise over run. My y-axis is counting by 5s. 5, 10, 15, 20, 25. So I went up 25. And then my x-axis is counting by 10s. 10, 20, 30, 40, 50, 60, 70, 80. So back on part B, it says to write an equation in slope-intercept form. So our slope, m, we know is rise over run. We said our rise was 25 and our run, was 80. If we reduce that in the calculator, we get about 0.31. Even if you had gotten slightly different points, our slopes would be similar. My y-intercept we can get from the graph or the table. The y-intercept is on the table, so we're going to use the precise y-intercept of 47.3. So we can use our slope and our y-intercept to write an equation. We have y equals 0.31x plus 47.3. It also asks us to interpret the slope and the y-intercept. So, our y-intercept of 47.3 is the life expectancy in 1900. This is increasing, so life expectancy age is increasing by 0.31 times per year. So lastly, C, use the equation to make a prediction about the life expectancy for a person born in 2020. We could use our equation. We could also use our graph. So we'll use the equation first. We have y equals 0.31x plus 47.3. X is the years since 1900. Y is life expectancy. We want to know the life expectancy, Y, for a person born in 2020, X. Well, how many years since 1900 is 2020? 2020 minus 1900 was 120 years ago. So our X value is going to be 120. So if we say, well, Y equals 0.31 times 120 plus 47.3, using our equation, we would get approximately 84.5 years. If we used the graph, we would say, okay, well, at 120 years, my line is about at right above 85, so maybe 85, 86. So from the graph, it's about 86 years. These are pretty close together. They're both reasonable conjectures. Oftentimes your homework will be graded, and because it's a general trend, as long as it fits within a reasonable span, it will be counted correct. If you are unreasonably off, for example, if you were to have made a conjecture saying about 70 years, that's not reasonable based on this data, so no, that would not be counted right. But as long as you continued with this general trend, numbers right within this area would be considered reasonable.